Hello and welcome to this KHL webinar, How High Strength Steels can help you reach your future goals, which we are bringing to you in association with ArcelorMittal. I'm Andy Brown and I am the editor of International Construction Magazine, and I'll be your host for this webinar. Firstly, I'd like to thank everyone who's taken the time to register for this webinar. We've had people from all over the world, which is fantastic. And we've had good numbers as well. So thank you very much. Just some quick housekeeping. This webinar will last for approximately 45 minutes, possibly a touch longer. And we'll be talking about high strength steel and how it can help companies, both in terms of it being the best quality steel to have in their products and equipment, but also with their drive to become more sustainable. Something that I think we can all agree is a true mega trend across the world and is a very important topic for all of us. I'd just like to highlight now quickly that you can ask questions of our expert panel, and indeed we encourage you to do so and to make the most of their knowledge. You can ask questions via the Q&A function, which you should see towards the bottom of your screen. And I will be keeping my eye on this throughout and asking any pertinent questions of the panel. So talking about our panelists, we're lucky today with the experts that we have. So I'd like to introduce them now. So we first welcome Jan de Moor, who is Marketing Manager for Heavy Machinery. Jan, thank you for your time. How are you?
Quite well, Andy. Thank you and welcome to everyone.
Great, thanks, Jan. And we're also joined by two experts from the R&D team of the company. So Sophie van Rostenberg, you wouldn't believe I've actually practiced it, and that's the best that I can do with pronunciation. So hello, Sophie.
I'm fine, thank you, Andy.
Great, thank you. And we've also got Lieven Brekker, who's the Product Development Manager for Ultra High Strength Hot Rodded Steels. Hi, Lieven.
Hi, Andy. How are you doing?
Great, thank you. So we do have a presentation which has been prepared, which we are going to go through. But before we get to that, I've just got a question, really to kind of try to set the scene a little bit. So as I said at the start, we know sustainability is a mega trend across not just construction, but all industries. Jan, maybe you could just give us an overview about how the steel industry is reacting to the need to be a bit greener.
Well, let me answer in that sense, okay, what we do at ArcelorMittal. We work at specific different levels, of course, okay, we are reusing, so reusing heat from our furnaces to heat surrounding homes and even our energy production. But also the reuse of gases, for instance, okay, for where we create, it's a pilot plant, okay, where we create bioethanol in Belgium. And then, of course, okay, the reuse of other what we call byproducts. For instance, okay, asphalt and paint industry, and the increase of the reuse of recycled steel in our steel mills or steel production. Then, of course, okay, we are producing, or we are going to start producing zero carbon, or at least, okay, we present our roads towards zero carbon or carbon neutrality with very heavy investments in new technologies, such as direct reduced iron, DRI as it is known. Also in the trend, of course, of the hydrogen economy. And then we have announced this already for our mill in Bremen, Ghent, and in Spain, Sestao and Gijón in Europe. And we expect, okay, that others are there to come. And on the other hand, of course, okay, we are also, you could almost say, provoking in the market a change in terms of product offer. And so, for instance, okay, to use less zinc in metallic coatings with new alloys, with the touch, for instance, of magnesium or aluminium, increasing thereby also, okay, the corrosion performance, but also, for instance, okay, biosourced paints within our range of organic coated steels. And then, of course, okay, one of our big areas is to produce higher and higher strength steels for various industries, of which a large contingent is present in this seminar, as this will allow, in fact, okay, to use less steel. And the less steel you use, in fact, okay, the greener the steel will become. But my first slide, in fact, is not so much about what we are doing, but more of course, okay, what the market is looking at and what challenges they face. We know that the market is successfully investing in automation and digitalization of the processes and products, and that's there is an increased pressure on cost and CO2 reduction. The challenge is then, of course, okay, to have products more and more competitive. And at the same time, the business needs to become much more sustainable. So in fact, a lot of work is done on manufacturing efficiency. Today, we will show you from our side the benefits to use high-strength steels as an answer to these kind of challenges. Those of today, and of course, okay, those also of tomorrow. And without compromising the performance of the end product, we can show you that the smart steel grade selection will help you to reach the next level of sustainable solutions at an affordable cost.
Great, thanks, Jan. I've just got a question, if I may, at this stage. I wonder kind of how the steel industry and you and your company in particular are implementing new technologies such as automation, which we've mentioned there.
Mm-hmm. Well, in fact, of course, okay, we can take an example, for instance, of our galvanization line in France. In a nutshell, we are completely redesigning the process with more automation, more control screens, for instance, per station or workstation, more mobile tools to work along the line, but also, okay, automated and digital shape control, for instance, for hot strip production with full data processing, including a closed loop in terms of, for instance, flatness or surface properties. But we could also talk about buying our steel on digital platforms with integrated EDI, for instance, okay, where certificates, mechanical properties can be digitally transmitted, but also order confirmations, ordering system by itself, so that it can be completely integrated for instance, okay, the road map towards Industry 4.0. But let me introduce now to you, okay, what we could achieve with high-strength steels. This webinar is based on the results of real case studies with real outcomes in terms of weight, cost, and CO2 reduction. To achieve these outcomes, we invite you to join our journey to a more sustainable use of steel. Our experts can help you to select the smartest steel grade for your application, and they can think along with your design team and suggest cost-effective alternatives. Thanks to our result-driven R&D efforts, we can support the introduction of new steel grades in your manufacturing facilities, by example, providing recommendations on bending, welding, corrosion protection, etc. This webinar will demonstrate the potential of high-strength steels on saving weight, increasing service time, and many more advantages, all contributing to reducing CO2 emissions.
Great, thank you very much. So now we reached to the point where, I mean, I say excitingly, but I am quite sad, but excitingly, I think so. We have a live poll to do, which we're going to be asking for your opinion. So the question is, what is your main or your key challenge today? So we have 5 different options that you can choose. So CO2 footprint reduction, fuel consumption reduction, increased functionalities and capacity, reduction of the total cost throughout the value chain, or automation in production. So I'm just going to launch that now. So you should be able to see that now on your screen, and you should be able to vote for one of those 5 different topics. I can see now live that people are voting, so thank you very much. I shall just leave that up there for another minute or so, or not a minute, but we're still getting the votes coming in, so thank you very much. It looks like at the moment CO2 footprint reduction has been chosen by the biggest majority of people. I'll give it another couple of seconds and then I will end this poll. Thank you very much again for everybody that has voted. I shall end that poll and I shall share the results so we can all see that. So we can see that 43% said CO2 footprint reduction, 12% fuel consumption reduction, 10% increased functionalities and capacity, 27%, so the second most popular answer was a reduction of the total cost throughout the value chain, and 8% said automation in production. So interesting results. Jan, I wonder if you have any thoughts on that?
Indeed. Okay, that matches pretty well. Okay, what high-strength steel can bring, what we in fact already instigated, and what I in fact summarized in my next slide. And so switching to high or even ultra high-strength steel grades opens really a door to new opportunities generated by their weight-saving potential and excellent bending properties. Especially, of course, when we consider weight reduction, lower fuel consumption, increased payload, increased service time, lower maintenance requirements, but for instance also an improved weldability, good paintability or direct paintability, and at the same time reducing the environmental footprint. Real life results have already proven the benefits of the use of high-strength steels, and as such at ArcelorMittal we are willing to go the extra mile. If we can go to the next slide, please. Thank you. We offer our customers a co-engineering service providing support in design, prototyping, sampling, testing, and applying for the final homologation. On the spot, technical assistance on bending, welding, painting, etc. is available to help you with the transition towards these new kind of steel grades and possible solutions. Our global presence assures a local production and availability of our products at your proximity, adding towards a green and sustainable supply chain. In our continuous strive towards improving your processes, we can now even offer X-Carb Green Steel certificates and certified recycled and renewably produced X-Carb RRP, as that is our branding. All these results in an attractive product range offering several brands with adapted metallurgy for dedicated applications. Armstrong is our main brand for hot rolled high-strength steel low alloy steels, up to 1100 megapascals and beyond. Typical applications are earth-moving equipment, trailers, trucks, tippers, buses, cranes, agricultural machinery, and railway wagons, but not to forget racks, lighting poles, and even profiles. Our offer of hot rolled wear-resistant steels, which we brand as Relia, in cut-to-length sheets and plates up to a hardness level of 500 Brinels, where the main use is equipment for excavation and bulk handling, crushing and screening, demolition, waste and recycling equipment, cement and other industrial applications. But we further expanded the range with our Cresabro discrete plate offer in low alloyed martensitic abrasion resistant plates up to even a hardness level of 600 Brinels for even the more critical wear parts. Looking at our Amstrong and Amstrong Ultra high-strength steel portfolio, our current range goes from 355 yield strength up to 960 megapascals yield strength, with in current development the 1100 range. Dimensionally, we can offer up to a thickness of 20 millimeters with a width of 2080 millimeters, available with superior surface aspect, excellent flatness, and minimal residual stresses. I pass now the word to Sophie van Rosterbergen. Sophie is heading the Applications and Solutions Department of the Global R&D Center in Ghent, Belgium. Her team handles projects in which the benefits of using high-strength steels become much more tangible, as we will show it. Sophie, the floor is yours.
Thank you, Jan. So I invite you now to have a look into examples taken from real-life projects in which typical S235 or S355 grades have been replaced by our Armstrong and Amstrong Ultra grades, reaching strength levels of 420 to 900 megapascals. So, but before diving into these examples, it's important to know that we can provide a full support, so from design to bending and welding, and even help in prototyping. So at ArcelorMittal, we have a team of experts that can handle numerical simulations to choose the smartest steel for your application. And we also have test equipment in-house to validate the new designs or prototypes in our labs in Belgium.
Hi, Sophie. Sorry to jump in. I've just got a quick question, if I may. I know that you guys are always kind of working on new designs and prototypes, while I understand, of course, there's some things you can't share, and I wouldn't want to get you into any trouble. Would you be able to maybe give us a flavour of some of the things that you guys are working on at the moment?
Well, so we will unveil some of our ideas in this presentation today. So I will present new designs and prototypes, some very recent, and you will see that our approach is not to force customers into 200% high-strength steels. But we try to have a more balanced approach, as in many cases, the right answer is a combination of various grades, some more traditional and some more innovative. So, and my colleague Lieven, he will talk about our current research programs. And here also, the idea is not to enter in a race for more and more strength, just like this, but also think about the processability of our innovations.
Great, thank you.
So on the next slide, I'm going to zoom in on a couple of example cases we've studied. So in the field of agricultural applications, for instance, we've looked into container bodies, where we switched from a lower strength S235, S355 grade to Armstrong 420 and 700. So this represented a 20% weight reduction and a 5% reduction in steel cost. So furthermore, also in this case, a redesign of the container body itself was considered, and 75 meters of welds were avoided, so which of course significantly impacts the manufacturing cost. Another example, so in the field of agricultural applications, is the hinged tow bar, so which is in fact the part which makes the connection between the tipper and the tractor. So here the S235 grade was replaced by an Armstrong 500 and an Amstrong Ultra 700 grade. And this represented a weight reduction of about 40% and a significant steel cost reduction of 25%. So in this, during this case study, we also investigated the manufacturing of the part itself, and we proposed to switch from the original patchwork-like welded structure to a bended structure, and so thereby avoiding very costly welding operations. So on the next slide, you will see other case studies in the field of yellow goods. So a first one is a dipper arm, for instance, where an S235 commodity grade was replaced by an Armstrong Ultra 700 MC, resulting in a 20% weight reduction. So a prototype was made and tested in terms of fatigue lifetime, and the design goal was by far exceeded in this case. So a second case was the bogie beam of an articulated hauler. So initially, the part consisted of a combination of cast part and steel sheet material. So the S355 sheet material was replaced by an Armstrong Ultra 700 MC. So here also in this case, a prototype was made. It was put on a fatigue test rig, and its fatigue lifetime exceeded 3 times the fatigue life of the current design. So in the field of lifting equipment, so we analyzed and optimized the beam profile of a telescopic crane, so a truck-mounted telescopic crane, aiming at improved stiffness. So here, the combination of the use of high-strength Amstrong Ultra or even 700 or even 900 MC, together with the design improvement. So those two facts made it possible to increase the reach and lifting capacity of the crane. So a last example in the field of lifting equipment is a forklift cabin. So the main challenge here is the fatigue behavior and also the impact resistance, because the cabin itself should of course protect the driver from falling objects. So detailed analysis was done using our simulation tools. And the majority of the parts, for the majority of the parts, the lower strength commodity grade was replaced by an Amstrong Ultra 700 MC. And this finally resulted in a 50% weight reduction. So a last group of applications we would like to highlight is the transport sector, and more specifically zooming in on a trailer chassis case. So we developed a steel solution replacing the S355-420 grade by an Amstrong 500 and 700 MC. So, and this case study has shown that the weight of a typical existing chassis can be reduced by about a quarter without affecting the performance. So the projected mass saving reduces fuel use and can save up to 4,000 kilograms of CO2 emission per year per trailer produced. So this will, of course, have a major impact on helping to achieve the goals of the European Green Deal, for instance.
Sorry, Sophie. Sorry to interrupt. I'd just like to jump in for a minute quickly, if I can, just to say that I have had some questions that have been sent to me kind of directly, which is great and it's fantastic. But just to kind of say as well that we do have the Q&A function, which is there, and that's the preferred method. So please, if you do have any questions, if you could put them on the Q&A function rather than kind of sending them to me directly, that would be best. We are looking at them. I don't know, Jan, would you be okay now? There's a question that's been asked that I think you'd be the person to answer. Is it okay if I just ask that of you now? Yeah, sure. Go ahead, please, Andy. So thank you for the question that's come in, and they just kind of ask, they're talking about obviously about high strength steel, and they just want to know if this is something that demand is increasing for rapidly, and they also ask kind of whether the technology that is used to produce this is that kind of improving all the time as well? Was that changing? Indeed, of course, the method of production is increasing all the time. And on the other hand, of course, especially now with focus on you could almost say greenification within the market, demand is, I could almost say, booming. Okay, great. Sorry, Sophie, I'll hand back to you now. I just wanted to make everyone aware that the Q&A function is open, and that's the best way to ask questions.
Okay, so what does it mean to use high-strength steels versus lower strength grades? So the projects I've just shown, they prove that successful transitions are possible. However, when shifting to other steel grades or changing manufacturing solutions, attention is needed to avoid issues. So, and this is where our customer support team provides you with valuable information on topics such as welding or fatigue. So first of all, it is important to choose the right combination of steel grades for your application. And when creating new designs, take care to ensure smooth geometry, which significantly improves the fatigue resistance. So you all know that welding changes the behavior of the steel. Welds and their heat-affected zones should not induce high stress levels. So we've developed specific welding guidelines which allow you to reduce the risk of cracks or creating weaker areas in the vicinity of the weld. When welding high-strength steels, care should be taken to limit the heat input, and we can provide you a suitable process window for welding, allowing you to select the best welding parameters using your welding equipment. Of course, we help you to choose a suitable filler wire, matching or overmatching the strength of the base material. When shaping a part, the bending radius and the bending gap is of utmost importance. So bending guidelines strongly depend on the thickness and should be aligned with the dimensions and the mechanical properties of the chosen grade, thus already anticipating springback. Over the past decades, we have supported many customers to succeed in achieving their goals, either by helping in the design, providing guidelines during the development and production setup, and by manufacturing samples for testing or in manufacturing prototype parts for performance testing. So for an update of the most recent achievements in steel grade development, I leave the floor to Lieven Brakke, my colleague. So within ArcelorMittal Global R&D, Lieven is the responsible product development manager for our ultra high strength hot rolled steel offer. The floor is yours, Lieven.
Yeah, thank you, Sophie, for providing some clear examples that indeed demonstrate the potential of high-strength steels on saving weight, increasing service time, and many more advantages, all contributing to reducing CO2 emissions. Our latest developments are aligned according to various axes to increasingly improve the benefits of these high-strength steel grades for a wide range of applications and without compromising the in-use properties. We distinguish different developments focusing on different aspects of product performance. So if we compare performance to the reference that we keep in mind, which is an Armstrong 355 MC and is shown as a tensile curve in green, the first group focuses on extreme strength, shown in blue. These steels go up to a yield strength of about 1500 MPa with still good bendability and toughness. And these steels are also suitable for wear and abrasion applications. And if I may, I can also indicate here a kind of short reply to one I've seen in the Q&A from Mr. Vazouras. So that the high strength reduces the ductility and elongation of these steels, which is true to a certain extent. We cannot deny that, but as you can also see, we can find solutions where we can triple, quadruple the strength, and the ductility is still at a very acceptable level of 10, 12, or even 15%. So it's with new metallurgical tricks we can circumvent the conventional issues to a certain extent, and that is also shown in the second development track in the red tensile curve, where we increase the strength with a factor 2, but the formability and ductility is completely maintained compared to the reference. So you can see this steel as a kind of ultimate Armstrong Ultra 700 MC. And then the third group of steels in orange has extreme tensile properties with a yield strength similar to the Armstrong 355 MC, but with a very high elongation and strength after deformation. And this type of mechanical behavior also ensures an extreme wear resistance in tough conditions. Now, as already demonstrated by Sophie, key points in the use of our steels in your application is that weldability, bendability, and fatigue performance, among others, are ensured. Therefore, it goes without saying that we do not compromise on these properties to ensure that our future Armstrong and Amstrong Ultra steels still fit with your needs.
Great, thank you, Lieven, and thank you for answering that question that came in as well. That's great. I've got a question of my own, which is, I'm curious, you know, is the amount of information that you have on your products kind of increasing all the time? And are you able to kind of give more definitive answers now to kind of different questions like weldability or lifespan?
Well, we are constantly generating additional insights in how these steels behave. It's an essential part of the iterative process to arrive to the final solution. Addressing properties like weldability or fatigue performance, to name one aspect of lifespan improvement, that's an integrated part of our development approach. And at the moment that we consider a new product ready for market introduction, all these demands have to converge into the new steel grade.
Okay, thank you. And I have kind of one more, which is, I understand that you guys are probably pursuing several routes in terms of developing, you know, the high strength steels of the future. But do you have any idea, or could you share with us any kind of information on kind of what you think might be the winner?
Well, Andy, the new products we develop must serve the needs of the end users. And there are many different types of applications in the scope that we cover. So we actually expect that different solutions might turn out to be the winners eventually.
Okay, great. Thank you very much. And we have, it's now time. So we have our second poll of the webinar, our second and our final one. So if you didn't vote in the first one, it's your final chance. So the question is, looking at the future, what is of main importance to you? So we only have 3 this time. So extreme strength, higher strength with the same dusticity, or extreme ductility. So I will now launch that. So you should all be able to see that now on your screen, and you have the opportunity to vote. So thank you very much. I can see that some people are already voting. It's quite exciting to see it change. At the moment, there does seem to be a clear winner, I would say. I should just give it another sort of 5 or 10 seconds or so. But yes, it looks like we have a very clear winner. So thank you very much, everybody, for voting. I'm going to end the poll now, and I'm going to share the results so that you can all see them, and we can see that, yeah, 91%, an absolute whitewash.
Winner.
Yeah,
so very,
very comprehensive. So yeah, Jan, what are your thoughts on this?
Well, as we can clearly see, of course, okay, the journey towards a more sustainable use of steel is by no means a one-way street. It's more than selecting the smartest combination of steel grades. At ArcelorMittal, okay, we are ready to support you in finding the best sustainable solutions for your application. And I really hope, okay, that we gave towards you a clear view of today's and tomorrow's solutions that we could provide. From our side, okay, we will continue to accelerate and we will continue and accelerate our progress towards extreme strength and extreme ductility, but also, okay, towards carbon neutral steel, without compromising on the performance. We continue to expand our offer to stronger yet easy to bend steel. Our products are available in the widest dimensional range. And thanks to our global presence, we assure local production and availability at your proximity. Our supplies are supported by a technical team with access towards our several research labs to provide customized recommendations in all steps of your manufacturing process. So in that sense, don't hesitate to contact us. So Andy, I leave it now up to you for the questions and answers.
Absolutely. Thank you very much. So yeah, so I have had some questions that have come into me directly. So I should just ask these, and please, obviously we have 3 kind of great people here on the panel. Please, you can whoever wants to, please speak up. So the first question asks if your products are available in other regions, such as, say, North and South America, India, Africa, etc. I guess they're asking if they're available in more developing nations, perhaps.
Well, I said, of course, okay, we have either-wise availability from local production, or either-wise from European or US production, or even production in India. So in that sense, yes, we can supply the materials throughout the world if needed.
Okay, great, thank you. Another question which is coming to me directly asks, how can we launch a mass saving and cost reduction study for our own products?
Contact us.
Simple as that?
Yeah.
Okay, well, I think towards the end, so we can see there that the contact details are kind of live on the screen, so you can get in touch. One of the questions that I was going to ask was that in terms of high strength steel, whether there's any kind of different. We've already kind of touched on it a little bit, but I wonder kind of whether there's any kind of different regions in the world where it's more popular. You know, would it be fair to say, would it be, you know, companies in kind of Europe or North America that we're more interested, or is this something that you're seeing kind of change as well?
Yeah, I don't know if it is indeed okay because of this European Green Deal, but it seems to be indeed okay that the Europeans are a little bit more into this than the rest of the world, you could almost say, depending, of course, in what principle you take. What we presented, in fact, was basically strip mill coils or sheets. In that sense, of course, okay, the discrete plate solutions, more highly alloyed, of course, and in a different thickness range, okay, are used throughout the world, and there's also much more availability throughout the world in that sense. Okay.
So we've got a question that's come in from Wilson Wong, who asks, in the previous examples of applications that we gave in the webinar, did the use of high strength steel usually lead to a lower amount of CO2 footprint?
Sophie, maybe you can answer, or shall I answer?
Yeah, well, indeed, and especially in the case of the trailer chassis, so the trail tag chassis, there indeed it was possible to reach a significantly lower CO2 footprint.
So in general, of course, okay, it means that, okay, a weight reduction does represent that weight of steel reduction, I should say, does represent, of course, directly a carbon footprint reduction, even depending on where it's coming from. And so in that sense, of course, okay, weight reduction is equal towards carbon footprint reduction. On the other hand, of course, we have our internal calculator, I would almost say, for a direct feasibility check, in fact, in how much carbon could be reduced, not only by means of weight reduction, or by means of weight reduction, cost reduction, and as such, carbon footprint reduction, just by definition of the steel grade by itself.
Mm-hmm. Okay, great, thank you. And there's another one, so that, sort of keeping on, I guess, the theme of kind of sustainability. We have another question from Ulf Armina. I'm very sorry, Ulf, for my pronunciation of your name. But they ask if you could talk a little bit about what your roadmap sort of towards being kind of more sustainable and kind of carbon neutral looks like.
In terms of production in that sense, or in terms of design of products? Because basically, of course, okay, our roadmap until 2050 to become carbon neutral is transmitted on our internet site. And so in that sense, we have a complete roadmap developed to become, at least, okay, to reduce our carbon footprint towards 2030 and towards 2050.
Okay, great, thank you. Thank you very much. The questions are coming in now, which is fantastic. So we have another one, which is: does the weight reduction have any negative effects on performance?
I think the idea is that it doesn't, for sure. Sophie?
Yeah, indeed. So when we start our optimization studies, indeed that the existing design is always taken as the reference case. So the idea is to have at least the same performance as the original design. So,
in that sense, of course, we always need to look at the current issues with the current design and possible future issues. It doesn't mean, of course, that just by lowering the thickness of the current design, that the performance remains the same. It can be, but it's not necessarily true. In that sense, of course, we are always looking if there is a design change, just by the profile by itself, possible. And so, for instance, of course, everybody will know, at least within a technical atmosphere, as soon as you reduce the thickness, the stiffness goes down, right? Because that remains equal, the Young's modulus in that sense. Not to use too much complicated words, but at least that will be the fact. So in some cases, of course, profile designs will change, and on the other hand, of course, we are also looking at fatigue behavior of welds. And to reduce the number of welds, if that's more or less in a nutshell.
Great, thank you very much. And there's another question here, which is they're asking about, it's perhaps not specific enough in terms of what they're asking about. They're asking about the heat treat property of the high strength steel. I don't know if anyone would just be able to maybe give background to that. They didn't seem to be asking specific.
That's one for Lieven. That's
well, it depends on what is exactly meant by the question. So if it's heat treatment to produce the steel, there, well, just for some we need to do a heat treatment indeed, like for the highest strengths, which is not too surprising, I think. If it is resistance against heat treatment, there we make sure that at least for let's say the common stress relief treatments and related treatments, that there is no issue with the material. Of course, yeah, if you go too high in temperature, you can destroy everything. But let's say in general applications, and our materials behave as you would expect it, let's say.
Okay, great, thank you. And there's another one. So someone has asked if for a bit more information about the ArcelorMittal green certificates.
Yeah, well, in that sense, maybe my previous answer was a bit too short. I don't know, and so check the internet. But if you check our website or even type in XCarb, so XCARB ArcelorMittal, you will find even on Google the most recent version, of course, eitherwise from our roadmap, but also the materials that we can offer. On the one hand, of course, as mentioned throughout the presentation, we have what we call the green steel certificates, basically stating that the steel you use is not necessarily recycled or renewably produced, but at least it shows the efforts that we are doing, and those efforts are taken into account with these certificates. And then on the other hand, of course, we have the XCarb RRP, so recycled and renewably produced, where dedicated on the product by itself. Basically, the 100% carbon neutral is, certified. In that sense, of course, it's a little bit of a mindset, in fact. The certificates are easy to use within a life cycle analysis approach, or when we mention, for instance, scope 3 carbon footprint reduction. On the other hand, of course, okay, the X-Carb RRP, so the recycled renewably produced, really is that coil, those sheets are completely carbon neutral produced. I hope that answers in a very much detail the question.
Great, thank you. So we'll just get, so as I said, the questions are still coming in, so thank you very much. So we'll just aim to kind of get to another 2 or 3 perhaps, and then we'll have to
wrap it up.
We'll have to wrap it up and call it a day. So we have a question from Zoltan, who says he's from the construction sector. Now, I don't know if you might not want to talk about specific kind of price points, which is fine, but he asks, which I think is a fair question, about the current difference in price between conventional mild steel and high-grade steels, and asks, are standard profiles widely available and accessible?
Profiles, of course, okay, we talk a little bit more about long products. It's kind of difficult to say, of course, but it's a different atmosphere as we are talking about it. So we really can't answer in that one, in the sense that, of course, okay, for long products, I think the offer that we have from ArcelorMittal is in the range of 500 megapascals and totally not comparable, for instance, okay, what we mentioned here in being 700 and 960. If you talk about welded structures, of course, where the complete profile is basically combined from plates or sheets, then of course, okay, yeah, there are price differences, but taking into account, of course, the weight reductions that have been presented, there will always be a cost advantage on the real life product, so calculated on the cost of the product, which will be cheaper. And so as you use less steel, yeah, okay, even the extra pricing of high strength steel will grant still a cost reduction. And that's the general case. Right? So we look at it from an engineering point of view. Nevertheless, of course, even if you have a 25% total steel consumption reduction, the cost saving will be there by means of high strength steel.
Okay, great, thank you. And I got a question from Steve Beardsmore, who asks, are there any problems with welding lower grade steels to high strength steels?
Yeah, good question. And yeah, depends a bit on which high strength steel is mentioned here. So it's not necessarily a problem, I would say, when the welding recommendations are followed. So for instance, welding an S700 to an S235 should not necessarily be a problem.
Okay, great. Thanks very much. So we said that the webinar was going to take 45 minutes and we're approaching kind of 50 minutes now. So I think we need to wrap everything up. So thank you very much for the questions that came in thick and fast towards the end. I know we didn't get to them all, but we did our best to get to as many as possible. And you can see the contact details there in case you do have any questions which weren't answered. So it just leaves me really to kind of thank our panel for their time and for answering all of those questions and giving that kind of great information. To say that a video recording of this webinar will be up on our website, so www.khl.com in the next couple of days. So watch out for that. So yes, just thank you very much for your time, and yes, see you again soon, hopefully. Goodbye.
Thank you. Thank you.
Goodbye.
Thank you. Bye-bye.
Bye.